All this stay-at-home stuff is giving me time to work on my harmonica, but looks like I better keep going. And maybe in a month, I'll actually have some skills at that. In the meantime, so I think we've solved the problem of getting these videos up onto YouTube so that you can try this as one of the ways that will get some new content to you. We're going to see how well this works. Try this today, and then it looks like we're going to be in this mode after spring break as well, so we'll see how it goes. So I'm going to keep this video fairly short to make it easier to upload and things. But I want to get into dilution. So we've had a little bit of practice with molarity. Molarity is how we measure concentration in chemistry. So the molarity, when we say the molarity, it is the concentration of a solution. It's how many moles there are, because we count quantity of a substance in chemistry in moles divided by the volume being in liters. So if I look at a solution and I say, okay, well, this one is going to be, let's say, concentrated. So it's got a lot of stuff dissolved. A lot of solute, that was a couple of the terms we did. Solute is the stuff that's dissolved in a solution. So the solvent is like, in this case, if this is salt waters, the solvent would be the water and the solute would be the salt. So this would be concentrated. So I'm trying to show there's a lot of salt in this water. And then if it's more diluted, maybe not so much salt, right? Less concentrated. So we measure that concentration quantitatively by saying, well, how many moles of salt are there per liter of solution? Now, if I build a certain concentration, so it depends on the moles and the volume. If I were to take this concentrated solution, let's say it was 2 moles per liter, or we call that 2 molar. So I have per liter of solution, I have 2 moles, 2 moles of salt. And let's say I'm going to take this concentrated solution, I'm going to pour some out. And let me make sure I stay on my screen. I'm going to pour out 100 milliliters of it. So I'm just going to take this concentrated solution and pour out some. It will have the same concentration, of course, because the salt is mixed, we say, homogeneously. So that means it's completely thoroughly mixed throughout, evenly distributed in that solution. So if I pour out a little bit, the concentration would be the same. So let's say I've cut it down to, so let's just assume originally I did have 1.0 liter. I had 1 liter of solution. I pour out 100 milliliters, which is 1/10 of a liter, or 1/10 of the solution. It has the same concentration. So how many moles, if there was 2 moles spread out through here, I pour out 1/10 of it, it will have 0.2 moles in 0.1 liter. So the concentration would be the same, right? So if I have 1/10 of the amount of the volume, I will have 1/10 of the amount of the moles. But it would still be, of course, the same concentration, 2 molar. Okay, let's work now, and so that's kind of a little bit of review of molarity getting into dilutions. And of course, I've given you some practice, and we've done some practice with just molarity. Let's go to dilutions. So I'm going to take this, so let's say I'm going to take this 100 milliliters of my concentrated solution, 0.2 moles in 0.10 liters. I'm going to take that and I want to dilute it down. I'm going to take that and I'm going to put it in a much bigger beaker. And so it'll only be down there. And then I'm going to add water, like just deionized water. So I took my concentrated salt solution and I dumped it into this beaker, and then I added water to a total volume of 1.0 liters. If I look at what I've done, and so here's what, so this was my concentrate down here. It was just 100 milliliters. Then I added water. Now my total volume is a liter. Well, the water that I added had no salt in it, right? It's pure water. So the only salt that's in this new diluted solution, and of course I'm going to stir it so it's all spread out, came from the concentrated. So how much salt is in this new solution that I diluted down? 0.2 moles. Right? So because I dumped 0.2 moles in there from my concentrated solution, and that's all the salt that's in there. What's my new volume? 1.0 liter. So what is the new concentration now that I've diluted it down? 0.20 molar. There are 0.2 moles of salt in this new diluted solution. And that's kind of how we do dilutions. Now let's look at, I'm going to give you a shortcut equation to do dilution problems. So let's set that up. So that's how dilutions work. But let's set up how this equation works. So let's look at our molarity again. Molarity equals moles per volume. If I want to know how many moles are in a particular solution, let's solve this for moles by multiplying both sides by V. So solving this equation for moles, moles equals the concentration times the volume. If I know the concentration of a solution and I know how much volume I have, I can calculate the moles that are in there. So let's, as an example, let's say I have 150 milliliters of, what did I do? Of a 2 molar solution. So the moles, so I'm going to change my volume to liters because the volume for this equation needs to be in liters. So I'm going to change it to liters. 0.150 milliliter, 1, 2, 3 is 0.150 liters, right? There are 1,000 milliliters in a liter. So now the moles in this solution equals 2.0 molar times 0.150 liters, which would equal 0.30 moles. Okay, now how are we going to use this for dilutions? So let me erase this. And what I had set up with that previous example is I had showed, hey, all of the moles of salt that were in my new diluted solution came from the concentrate. So what we can say, and this is of course true of in all cases, moles of concentrate. Sorry, I'm going to put that moles in the concentrate. The moles of salt, or whatever the compound I have in concentrate, equals the moles in diluted, in diluted solution. I won't write solution there. So all the moles in the concentrate, the number of moles in the concentrate equals the moles in the new diluted solution, because all I did when I diluted is add water. I didn't add any other solute. Okay, so let's look at how we would solve that. We just had said and I just showed before, the moles equals the concentration times the volume. So let's now write our equation. The moles in the concentrate is concentration of the concentrate times the volume of the concentrate. Sorry, let me write that bigger, because concentration of the concentrate times the volume of the concentrate. The moles of the concentrate equals the moles of solute in the diluted. My new concentration of diluted times volume of my diluted solution. And this is our shortcut equation. And let me show you how that works now. So I'm going to leave that there and just erase this top. But it's derived in this way. This is how many moles of solute, whether it's salt or some other compound, are in my original concentrate. That's equal to the same number of moles in my diluted solution. Let me write a problem, a typical problem. What volume of 3.00 molar or moles per liter solution is needed to make 2.00 liters of a 0.120 molar solution. Okay, we're going to use this equation. So here's just a typical problem. What am I given? What volume of, in other words, that's my starting solution. That's the molarity of the concentrate. So let me write it below. Molarity of the concentrate equals 3.00 molar. That's my new solution that I'm starting with. I'm going to take that, add water to it to make my new solution, a diluted solution, which is only going to be 1.120 molar. And how much of this diluted solution do I want to make? Liters. And at that point, so we just identify what is given in the problem. What do I need to find? The volume of the concentrated solution equals, I don't know. So let's plug in now. So I'm going to erase this problem, plug those numbers in, and solve. Molarity of the concentrate is 3.0. I'll drop a 0 momentarily. Times volume of concentrate, that's my unknown. Molarity diluted is 0.120. And volume of diluted, 2.00. I multiply those together and I say my volume of the concentrate. How much do I need? 0.080 liters. I can erase this now. That's not usually how we would talk about this. If I have this small a volume in liters, I'll usually switch that to milliliters. 1, 2, 3, and I should have had another 0 on there. 80.0 milliliters. So how would I make this solution? By calculating that, and this is something we do all the time when I'm preparing solutions for a lab or something. I would say, okay, let me take my 3 molar solution that I got, my concentrate. I'm going to take that, add water until I have 2 liters. So I'm going to take 80 milliliters of my concentrated solution and then just add water until I got a new volume of 2 liters. If I do that, I know that I will now have a concentration. I will have this solution. 2.0 liters of a 0.120 molar solution. All right, so that's how we'll use that equation. I've got some practice in the attached Google Docs.